Good morning. Today we will see structures in C. This is with respect to implementation of linked list. In linked list, we need to define nodes. So for that, structure concept is required. And in that perspective only, I am going to refresh the concepts of structures in C. As you know, structures in C is a collection of some variables, and it has been given one single name. So declaration requires struct keyword, then tag name, some name is given, and members are declared. Suppose member 1, some data type, member 2, and this goes on. And you can give here variable names also. So this is generalized syntax of a structure. Structure is a keyword. This will be an identifier. This will be identifiers. Under this name, we are defining these members. This is collection of variables, and this will form a name of that collection. Like in arrays, where similar data type can be given, but in this, different data types can be given. This might be integer, this might be character, this might be double, anything. So as an example, suppose I want students' data to be collected. Student will have logical information, like student will have its roll number, its name, then percentage of marks. Many things will be there pertaining to student. If we want to store that student's information, we cannot use arrays there, because student's information contains different data types, such as roll number might be integer, then name might be a string, then percentage might be a float. So different data types are there. So structure can be used in that case. So I'll say int row number. Suppose I want to give name, so char name of some 20 characters, then float percentage, now this can be a student's logical student's information. What happens? A student may have roll number, name and percentage. If we want to store each student's information, these three members we will be reading, right? So logically what we have done is, these three different typed variables, we have collection, and this collection's name is student. Yes, we are forming a new data type here. By structure, we are forming new data type, right? So how we can use these structures? This is declaration. How to define that definition of variables? How we can create variables? This is now type. One type has been created, yet memory is not allocated. See, we have said this is just declaration. Memory is not allocated. So how to create variables of this type? Now you should know what do you mean by creation of this defining variables. When I say integer x, what will happen? X will be given some memory location and value of some integer value will be stored in x. So memory is allocated here. This is declaration as well as definition. Declaration says compiler that x is of type integer. This is also definition. Definition means memory is allocated for this, right? Now this structure declaration is just mere declaration. Memory won't be allocated. When memory is allocated, when you create variables of this type. So how to create variables of structure type? There are two ways to declare. Now, one way is, you can say directly, in between this curly brace, closing curly brace and semicolon, if you give variable names like student1, what will happen here? S1 is now variable. Now this is definition. One variable of this type you have created. So what will happen? One memory chunk. See, roll number will be given 4 bytes. This will be given 20 bytes. Float will be given 4 bytes. This 28 bytes will be given to S1. 24 bytes will be given to S1. And this is named by S1. This will be for storing roll number. This will be storing name. This will be for storing percentage. So this much memory is allocated for S1 when you create variable of that type. Right? This is one way. Now you can create many number of variables also here. Like this, S2, S3, this way, many number of variables can be created here. So, how much memory will be allocated? For S1, 28 bytes, for S2, 28 bytes, for S3 also 28 bytes. So, this way, when variables are created, then only memory is given. Else, if you are writing this way, this is just declaration. Declaration, memory won't be given because variables are not created here, right? Now this is one way. This is one way of creating variable of this type. Now the other way is after declaration also you can create your variables like this. Struct student. Now this is data type you have created by this. This is data type. This is user defined data type now. Now you want to create variable of this type that I am giving identifier as S1. Now this is other way. S1 is created of type struct student. Right? So S1 will be allocated now 28 bytes here. So these two ways we have seen first. Then how can we accessing of structures? Now there is a dot operator. We say dot operator that is used to access structure members. As you know, I can initialize the variable at the time of declaration also. I'll initialize this. First member is roll number, I'll give 10. Second member is name. In double quote, I'll give name as ABC. this is string, and percentage I'll give 80.99 and semicolon. Now what will happen by this initialization? 10 will be assigned to S1's roll number. ABC will be assigned to S1's name. 80.9 will be assigned to S1's percentage. Right? Now, how dot operator can be used for accessing this information? By this, what is happening? See, S1 will be allocated 28 bytes. 28 bytes. First field is the roll number field, that will be given 10. Second field is name. Name will be given as ABC. Percentage field 80.9. And this is known as S1. Now I want to access this structure members. How I can print these values? I want to print, suppose. So how can I print? Now whenever I want to access this value, what is identifier for this? In structure variable, structure roll number. Now roll number, name, percentage field. Whose roll number we are accessing? S1's roll number. If you want to access name, name of whom? S1's. Percentage of S1's. Means always whenever you are accessing these variables, you should know variable name of structure. Then only you can access these members. So what is name of the structure? S1. So if I want to access this roll number field, I have to use this way, S1's roll number field or S1's name field or S1's percentage field. This way it will go on. So this dot operator is used. What is type of this S1? S1 is of structure type you have created. What is this? This is member of a structure. Member of a structure. So for accessing any member of a structure, we have to use dot operator. Just writing roll number won't be sufficient, because whose roll number? Because we are storing in structure. So S1's roll number, S1's name, S1's percentage. Now consider this is accessing. Consider this as whatever normal variables you have used till now. If suppose integer x is given 10 and you want to print this x value, what you might have done? Printf %d and x you might have done this way, right? Similar way, if I want to access structure variable after this, if I want to print roll number, what I have to do? %d, because this is integer type in student structure, and I have to give S1 dot roll number. That's it. This is accessing. So this way we can access S1's roll number I am printing. This is just like normal integer, whatever you might have done in printf. So x you are printing here structures value you are printing, members value you are printing, S1's roll number. So by this statement what will happen? 10 will be printed here. 10 will be printed. Right? So this is dot operator that we can use for accessing any member. Similarly, you can read the information instead of initializing here. I don't want to initialize here, I want to read the values. You can write scanf for that and accessing that location again will be in the same way. What way? Suppose I want to print enter roll number, then scanf is written this way, scanf, we are reading integer value integer value. And scanf we have seen, this is by reference, you have to pass ampersand. Now where you want to read, where you want to store that whatever read value, we want to store in S1's this roll number field. So address of S1's roll number field we are giving, that's it. If you want to read name, for strings you know there is no need of giving. Suppose I want to give %yes. Then here ampersand is not required for reading strings. So S1 dot name. Then scanf percentage float value you are giving ampersand S1's float. Normally whatever way you have written scanf till now, the same way it will go on for structures also. It differs only in where you want to store. S1's roll number field you want to store this whatever you are reading from keyboard. S1's name you are storing name string value into S1's name field. This way printf, these are we can use for printfs also. So this is simple way of accessing through dot operator. Dot operator gives us which field or which member you are accessing from a structure, right? So this is all about accessing. Now for our linked list concept, we should know pointers to structure. Pointers to structures. Already we have seen pointers. How we can create a pointer variable here? We can create pointer variable. This is type. If I write star ptr, now what is type of ptr? ptr is pointer to struct student. So what will happen here? See, this memory is not allocated for structure. This is for pointer variable. The size will be same. Let it be integer pointer. Size of that pointer variable will be same. So this pointer may point, yet we have not initialized that. Now I have one variable struct student. Yes, I am initializing this with 10 A, B, C, 80%. And if I give PTR is given address of yes. So by this what is happening? See, yes is created of 28 bytes. These are initialized 10 ABC and 80. This is initialized. Now by this C, address of S we are giving to PTR. What is type of PTR? Pointer to student structure. So pointer, this PTR can store address of any student structure variable. This is student structure variable. So you can give this. So by this what it means is PTR is pointing to this structure. PTR is pointing to this structure. Right? Now there are two ways to access this structure. How we can access? The first way for this example, either if you want to print roll number of student, I can use S dot roll number. This is one way, because S is normal structure variable. So dot operator can be used for accessing the member. But the indirect way through pointer is also there. What is indirect way now? If I want to use pointer, see, this is name of this structure variable is yes. S dot roll number, S dot name, S dot percentage you can access. But similarly, through pointer also indirectly you can access the members also. So the way for that is I can use star ptr dot roll number. See, I am accessing indirectly. I am not using yes now. I am using pointer variable. Star ptr. We have seen already what mean by this indirection operator star. Star ptr. What is the star ptr? Value pointed by ptr. Value pointed where ptr is pointing to this structure, right? So value pointed by ptr is this block. Its roll number field you are accessing. So this is the way. This parentheses are necessary for this because dot has higher precedence than star. What we want is we want to give this indirection operator higher precedence for accessing. So this parenthesis set is must for accessing through pointers. But this is somewhat clumsy way. This is somewhat hard for using. So there is another easiest way of accessing the structure members by means of pointer variable. Instead of using this syntax, the equivalent syntax for this with other operator is this arrow operator. Arrow operator. Now this way also you can access. These are equivalent. Equivalent now. What is this? Instead of using this complex way, this dash and greater than symbol without space forms one operator, arrow operator. Now this says this pointer wherever it is pointing, its roll number field. This is one operator. Now which is easier way when you are accessing with pointer? This is easiest way. So this way we can access the members of structure through pointer variable. Either you can use this way for accessing or this way of accessing. But this way is easier to access. Now I will show for this case through the pointer variable how to print the values. We have initialized this structure. How to print the values? See, printf. Roll number I want to print. Roll number of a student is %d. At this %d place, I want to print this 10. How to access through pointer? PTR's roll number field. PTR's roll number. Now see, this arrow operator I have used. So this way you can print the values or access the values through pointer variable. This way you can do for others also. So this is the way, this through pointer variable how to access, right? So we have seen here you could write this way also, star ptr in parentheses dot roll number also. This way also you can access, but this is easiest way to use arrow operator, so we use this way. So this whatever lecture I have taken, this is only refreshing your concepts of structures, because these concepts are needed for implementation of linked list, because we will have a structure pointer and there is a concept of self-referential structures that is also needed. Self-referential structures. What do you mean by self-referential structures? Structure referring to itself. Structure referring to itself. I am human. I am pointing to other human. So when I have that address, I am pointing to a similar category. So here instead, if suppose I have this structure and I have a member like this, struct student star next. Now next is pointer to struct student. Means if you are creating a variable of this type, struct student yes, what will happen? See, yes will be given memory. First field is roll number, second field is name. What is third field? Third field is pointer to struct student. Pointer means what? What is pointer variable? It stores address of that type. What is type of next? Struct student. Where next can point? To struct student type. Struct student type. So here it might have roll number, here it might have name, but this will have address of some structure variable of this type. So some structure variable you have created, suppose this is some structure variable. Now what it can store? It can store address of some structure variable. So this address might be on 1000. So this, if you assign the address, this may store address of something. Means this is referring to itself. This is pointing to the same type, similar type. So you can store address this way. Now this field may store address of another variable. This may store another node's address. Now this self-referential structure is used in linked list. What is self-referential structure? When you have a member referring to itself. This is a reference. This is pointer variable means reference. This is referring to itself. That is self-referential structures. So this, for node creation in linked list, we require self-referential structure, where one field, one member will have a reference. So we'll see in detail later when we implement linked list concept, right? We'll stop here. So refresh all these concepts once again so that we can start linked list concepts.